Let us look at definite integration, and we're going to see that definite integration can be used to find areas. When you integrate a function, say you have the integral of f of x with respect to x. This is indefinite integration. Indefinite integration, right, is indefinite. Why? Because you did not define any boundaries of the integral. Now, what does that mean? Let us see. If you do this, integral from a to b of f of x dx, this is definite integration. You have defined the boundaries. You're integrating between x equal a and x equal b. In the top one up here, it's indefinite because you did not say where you started integrating and where you ended. All right? So this one is indefinite integration, and this one is it should have been an E. Definite integration. All right? Now, let us say that you are going to integrate a function. Let's say you integrate. And that function is 1. You integrate the function 1 from 0 to 1 with respect to x. What does that mean? All right. Here, you're going to integrate 1 with respect to x. Remember now, 1 means 1 times 1. And if you want to show the power of x, 1 is the same as x to the 0. And what you do when you integrate, you add 1 to the old power to get a new power, and you divide by the new power. But this is x raised to the power of 1, which is really 1 times x to the power of 1 is just x over 1, which is just x. Now, how you show the integral and the steps, the boundaries from 0 to 1, to show them what you do, put what you're going to what you're integrating in square brackets, the lower boundary on the bottom right and the upper boundary on the top right. So you found x. Now, suppose we add the constant of integration here. So it's x plus c. And you are integrating from 0 to 1. What you do now is this. X is 1 at first. So what you're doing is the same as 1 plus c. Then you substitute the upper boundary for x in the function minus, and you substitute the lower boundary for x plus c. So it's 0 plus c. All right, what does that amount to? Let's remove the bracket. This is 1 plus c, all right, minus 0. When you remove the bracket, this will be a minus c. So let's put like terms together, number with number, c with c. 1 minus 0 plus c minus c. So this amounts to 1, c minus c. Now the fact is, if you're doing definite integration, you will not need to put the c. In fact, you shouldn't even bother to put it, because you will end up with two c's that subtract each other. So all you're left with in the bracket is x. So you don't need the constants of integration, because you'll have two of them and they will subtract. So let's erase them from here. So it's 1 minus 0, which is 1. Alright? So the integral from 0 to 1 of 1 is 1. Now, the function in this case is 1, which you could write as y equals 1. Now, here, what you really did was this. If you have a graph, y and x-axis, and you draw the line 1, trying to make this line straight and level, this is 1. When you integrate between 0 and 1, what that means is that you have 0 in the middle here, 1, 2, 3, and so on the x-axis. This is the curve y equal 1, or the line. It's a straight line, what you could call it a curve 2. You're going from 0 to 1. So if you have a vertical line at 0 and a vertical line at 1, what you really did was to find this shaded area. The shaded area is 1 wide and 1 high, which is 1. Alright? This is the line y equal 1. So this represents the function, and you're going from 0 to 1. Alright? Now, what you really did was to find the area bounded by, there are 4 lines here. You have the line x equals 0, which is the y-axis, and here this is x equals 0, the line x equals 1. So you have the x equals 0, which is this line, the x equals 1, which is this line, then the x-axis, which is here, and the curve y equals 1, which is up here. So let us highlight them. The area is bounded by x equals 0, x equals 1, the x-axis, and y equals 1. So the area inside here is what you just found, which is 1. Alright? Now, what this is saying then is that if you integrated from 0 to 2, then the answer should be 2. Let's try that. If you go from 0 to 2, then all of this will be the shaded area, which is 2 units. Would it work? Alright. Y equals 2. You want to integrate y. So you integrate from 0 to 2. Y equals 1. Let me start that part again. The function that you're integrating is y equals 1. But you're integrating from 0 to 2, which means from this line to this line, of 1 dx. Now, when you integrate 1, you get x, as we saw earlier. And you put your square brackets, the lower boundary on the lower right, the upper boundary on the upper right. So, you don't need, remember now, you don't need the constant of integration because it will subtract itself anyway. 2 for x, substituted for x, will be 2 minus 0 substituted for x will be 0. 2 minus 0 is 2. So you see the area, this shaded area here is really 2. Well, now, let's try something else. Suppose we do this. Let's erase this. Erase all of this. And we do this. We want, first of all, let's look at the graph. This is still the line y equals 1. This line. Let me try and draw that again. Make it more level and straight as I can. And you want to find the area between 2 and 5. So you have 1, 2, 3, 4, 5. So the area between here and here, it would be 1 high and 1, 2, 3 wide. So it should be 3. 3 times 1 is 3. 3 wide times 1 high is 3. It forms a rectangle. So the area that we want to calculate, let me shade it. And shade this area here. And this area, since it is 3 wide and 1 high, it should be 3 square units. Let's see. You integrate from 2 to 5 of f of x, which is 1 dx. When you integrate 1, you get x. You have your square brackets, and then on the lower right of the square brackets, you have your lower boundary, which means this line. Then on the upper right, you have your upper boundary. Now, you substitute 5 for x. It's 5 minus, then you substitute 2 for x, which is 2. And you get, 3. It is really 3. Let's put the unit square, because we're dealing with an area. So, we have used integration to find this area. Now, you could very well use simpler calculation to find the area because it's just a rectangle. But later on, we will see more examples, including a graph that might look like this. You have your y on the x-axis, and the graph runs straight line going in this way, and you integrate it from here to here. So you would find this area. Now, of course, you could use your rectangular calculations because this would consist of a rectangle and a triangle. So you could use those calculations, no problem. But where you would not really be able to use simpler calculations to get an accurate value of the graph would be a situation like this. You have your x-axis and your y-axis, and you have some sort of curve function, and you're integrating from here, call it a, to here, call it B, and you want to find not an estimate, not some approximate value, but the exact value of the area under this curve. You want that area, and it must be exact, not an estimate, but exact area. Now that is where integration to find the area would become quite useful. All right, so this would be, for example, y equal f of x, some function. This look like it would be a cubic function. I need to find the area under the function. It enclosed by the curve or the graph of the function, the line x equal a, the line x equal b, and the x-axis. All right, so we'll continue looking at this topic in another video, so I will see you.